All right, ready to dive into another paper.
Absolutely. Always excited to see what's new in the world of machine learning.
Well, today we're looking at few-shot task learning through inverse generative modeling. And it's all about teaching machines with, well, just a handful of examples.
Yeah, this is a pretty big departure from the usual. Like, usually you need mountains of data to get AI to do anything interesting.
Right, exactly. But this is exploring, like, how much can we teach with just a few demonstrations? Like, think learning to do a jumping jack, but you only see, like, 2 examples. Could you figure it out?
Definitely a fascinating concept. And I think to really appreciate this paper, we need to kind of understand where it fits in the whole landscape of machine learning.
Okay, so, like, what's the history here? What led up to this?
Well, so this research kind of sits at the intersection of 2 big areas, few-shot learning and generative models.
Okay, so back up a bit. Give us like a mini history lesson on those 2 things.
Sure. So few-shot learning. Early attempts, they were pretty limited, like relying on handcrafted features, rule-based systems. It was sort of like trying to teach a computer to recognize a cat by programming in like pointy ears and whiskers.
But that wouldn't work very well, would it?
Yeah, you got it. Like, not all cats have pointy ears.
Yeah.
Right. And then as machine learning techniques got more advanced, we saw more data-driven approaches. Things like support vector machines, nearest neighbor classifiers. Those allowed us to, learn from limited examples.
But they still weren't perfect.
No, not really. They still struggled, especially with like complex data or unseen data. Simple tasks, okay, but extrapolate knowledge to new situations, not so much.
Okay, so then where do generative models fit into all of this?
Right. So instead of just classifying data, generative models, they try to learn the structure of the data itself. So they can generate new examples similar to, but not the same as, the data they were trained on.
So it's not just memorizing, it's more like understanding the underlying like rules of how things work.
Yeah, exactly. A great way to put it. And in the past decade or so, generative models have made like huge progress. And this is because of deep learning, things like variational autoencoders, diffusion models. These models are creating crazy realistic images, text, even music.
Yeah, like those AI image generators that are everywhere now, right?
Exactly. So this paper takes those 2 things, few-shot learning and generative models, and kind of mashes them up in a new way. That's really the big idea behind few-shot task learning through inverse generative modeling, or as the authors call it, FTL IgM.
FTL IgM. Got it. So how does it actually work? What's the secret sauce?
Well, the core idea is first, you train a powerful generative model on a massive data set of like basic tasks and their descriptions. Think of it as giving the model like this foundation of knowledge, how actions lead to outcomes.
So like teaching it basic physics or something.
Yeah, something like that. And then when you want to teach it a new skill, you only need a few examples. Instead of retraining the whole model, FTL IgM uses that existing knowledge and uses these new examples to figure out the concept behind this new skill.
Huh. So it's like it already has all these building blocks and now it just needs to figure out how to like assemble them in a new way.
Exactly. And what's key here is it doesn't just memorize the specific demonstrations, it learns a more general representation of the task. So it can adapt to new situations and even like generate new behaviors it hasn't seen before.
Okay, so I see how this is different. It's not just matching what it's seen before. It's like actually understanding.
Precisely. And that's where it gets really interesting.
Yeah, hold on. Let's pause there for a second. We'll come back to that in just a
So where were we? Oh, yeah, FTL IgM and how it really gets things.
Yeah, you were saying gets interesting.
Right. Well, it achieves this deeper understanding, like you said, through 2 really key features of generative models, interpolation and compositionality.
Okay, those sound complicated. Break those down for that. What do those actually mean?
All right, let's start with interpolation. Imagine you teach this model, like a simple task, okay? Move an object from point A to point B. Now, give it a starting position it's never seen before, somewhere between A and B.
Okay.
So with interpolation, the model can still figure out, like, how to move the object to point B, even though it hasn't seen that exact starting point. It's kind of like filling in the gaps.
So it's not just like memorizing the exact steps. It's learning the general idea of move towards B.
Yeah, exactly. Okay, now, compositionality. This takes it even further. Say the model has learned 2 separate tasks, right? Move something horizontally and move something vertically. With compositionality, it can combine those 2 to create a totally new behavior, like moving diagonally.
Oh, wow. So it's like, okay, it's like learning the alphabet and then using those letters to make new words.
You got it. And that's what makes FTL IgM so powerful. It can take these basic things and, kind of combine them in new ways.
That's cool. So the researchers, they like tested this out. Did it actually work?
Oh, yeah, they put it through its paces. Lots of scenarios. Object rearrangement, navigation, human motion capture, even like real robots.
Okay, wow, a lot of stuff. Any
Mm.
specific examples that really stand out?
Well, this robot manipulation one is pretty cool. They gave the robot a few demos, how to pick up a block, put it in a specific spot. Then they changed it up, introduced a new block, something the robot had never seen before.
Oh, so like make it harder.
Yeah. And what happened? The robot figured out how to handle this new block. It used what it had learned from those first demos.
So it wasn't just mimicking the exact movements, it was like understanding the concept of picking up and placing.
Precisely. And that's where FTL IgM really shines. It takes that limited info, extrapolates to these new situations. It's a level of like generalization that we haven't really seen before.
This is pretty mind-blowing stuff. Are we like at the point where AI can learn anything?
Well, hold on. Let's not get too carried away. It's impressive, but there are still limitations.
Okay, yeah, that makes sense. What kind of limitations?
Well, I mean, think about it. The model's knowledge, it's still based on what it was trained on. So if you ask it to do something completely outside its experience, it's going to have a hard time.
So it needs that base knowledge to build on.
Yeah. And another thing, these generative models, they're computationally expensive to train. Lots of data, lots of processing power.
So even though it uses less data for specific tasks,
Mm.
that initial setup is still a big deal.
Right, exactly. And to be fair, the paper acknowledges this. It's not saying this is like the end-all be-all solution,
Hmm.
but it's definitely a big step forward.
Definitely. Okay, so we've got this new system, FTL IgM, pushing the boundaries of few-shot learning, but I think it's time for our novel notions segment. Let's get a little creative here.
All right, I'm game. What have you got?
Well, we've been talking about robots learning from humans, but what if we flipped it? Could this FTL IgM help humans learn better?
Oh, interesting. Go on.
Like imagine a system that could like analyze how you perform at something. Could be a sport, playing music, anything. And it could figure out your strengths, your weaknesses, and then like create a personalized training plan.
Okay. Yeah. So instead of a coach, you'd have an AI system guiding you.
Right, like a 24/7 personalized tutor, helping you learn faster and more efficiently.
There would be like some challenges, of course, like making sure the AI can really understand human performance and give feedback that's actually useful.
And yeah, the ethical side of things too, like how much should we rely on AI for personal development?
Definitely a good point. We have to be careful with this kind of stuff.
But I mean, the possibilities are really exciting, right?
Mhm.
Imagine if anyone could learn anything quietly and easily, no matter what their background is.
Yeah, that would be incredible. A future worth striving for sure.
Okay, well, I think that wraps up our deep dive into few-shot task learning through inverse generative modeling. It's been a wild ride, from the history of few-shot learning to the specifics of FTL IgM, and now even imagining how it could change how humans learn.
It's amazing to see how this research is changing our understanding of what's possible and how we think about learning itself.
And for our listeners who want to learn more, you'll find the link to the paper in the show notes.
Definitely worth checking out.
All right, until next time, keep those minds curious, and we'll see you back here for another deep dive into the world of machine learning. So we've gone deep on this whole world of like few-shot learning and generative models, but what does it all mean, for our listeners out there? Why should they care about this whole FTL IgM thing?
Yeah, good point. Got to connect it back to the real world, right?
Exactly.
Well, I mean, think about it. More adaptable robots, robots that can like learn new tasks super quickly, even in like messy, unpredictable environments.
So not just robots that do the same thing over and over in a factory, but robots that can like handle new stuff on the fly.
Right. Imagine like disaster relief robots. You could train them really fast to navigate, debris or do search and rescue just by showing them a few examples.
Whoa, yeah, that would be amazing. Instead of waiting for someone to program them, they could just like learn on the spot.
Exactly. And it's not just robots, right? Think about like education, AI systems that could personalize the learning experience for each student, just from a few examples of how they learn best.
Yeah, no more one size fits all.
Mm.
Everyone gets their own like custom-made learning plan.
And I mean, it goes even further. Think about how we use technology every day. What if you could teach your phone new tricks just by showing it?
Oh yeah, no more reading those super long instruction manuals, right?
Mm.
Our devices could learn directly from us.
The big takeaway here, I think, is that this paper, it's really pointing to a whole new way of thinking about machine learning. moving away from huge data sets, brute force computation, and more towards like human style learning, where machines can learn from just a little bit of data and then apply that knowledge to totally new situations.
Yeah, so it's almost like we're teaching machines to think more like humans,
Right.
to learn from experience, adapt.
Absolutely. It's opening up these crazy possibilities for the future, where AI systems can really collaborate with humans, learn with us, help us solve all these complex problems.
Well, folks, I think we've officially reached the bottom of our deep dive into few-shot task learning through inverse generative modeling. We've covered a lot of ground today, from the history of few-shot learning to the nuts and bolts of FTL IgM, and even some pretty wild speculation about the future of learning itself.
It's always exciting to see how research like this pushes the boundaries and gets us thinking about what's truly possible.
And if you're as intrigued by this research as we are, you can find a link to the paper in our show notes. Be sure to check it out.
Definitely worth a read.
All right, that's it for this episode. Keep those minds curious, and we'll see you back here soon for another deep dive into the fascinating world of machine learning.